So welcome back Solid Edge enthusiasts. Today we are going to dive into four game-changing tables used in Solid Edge. The tables are part list table, whole table, vent table, and general table. These aren't just tables. They are your secret weapons for efficiency in complex assemblies. So stick around to learn how to leverage them for your next project. So to start with, we'll take this assembly for drafting. Say file, new, drawing of active model, say OK. I'll keep the view as isometric view only. Just place the view. Now if you want to show this view in exploded view, it is necessary for us that the assembly must be exploded in the assembly stage, as well as the exploded view should be saved as a configuration. Then only you can explode it here. So I've already exploded this assembly in assembly interface, and now I'm going to show the view as an exploded view only here also. So for that I'm going to select the assembly, say right click, say properties, and in properties you will get this option, that is model view or zone. Just click on this option and select the required configuration. So I've saved the configuration by the name of DCF, so I'm selecting that and just say apply and OK. Now you can see around this view one rectangle is appearing. It is just asking you to update the views. So whenever this rectangle is appearing, we are going to update the views. You can see after updating the view, the assembly is coming in the exploded form. So after exploding this assembly, we are going to go for part list table, also known as bill of material, BOM. So here we are taking BOM only, but the name is changed in Solid Edge. So here it is showing the name as part list. Select the part list table, click on the required view and you will get the table here. Now table is showing four columns: item number, file name, author and quantity. We'll see this later, and how to edit the table and go in properties. We'll see that later. First we'll go on the balloon options as well as how to arrange the balloons. Now if I drag any one balloon, it is not going to be dragged side by side. It is going to follow this line, the reference line for the balloons. So if I want to move it independently, you must delete this balloon line. So I'm going to delete the balloon line. Now the balloons can be dragged independently as required. Wherever you want to place them, you can place them. But still you can see in each balloon, there are two numbers being shown. The bottom side number is showing the quantity of the part and the upper number is showing the part number. Means when the part was made, which was the first part, which was the second part, and that series. So we can directly go for the table in this form of the balloon only. But suppose if we want to remove the quantity number and just want to keep the item number here, then you just need to select this option, that is smart select. We are going to say smart select and select any one balloon. Say OK. After selecting one balloon and saying smart select, all the balloons present in this view will be selected. Just put off this option, that is item count. Now only item numbers are being shown. Suppose if I want to increase the height also, so I'll change the value of text scale as, instead of 1 I'm going to take it as 2 and say OK. So after saying OK, you can see here the balloon size text has been increased. After balloons we are going to move towards table. Just right click on the table, go for properties option, and in properties we'll see this tab, that is columns. So in columns you can see here all these four titles are nothing but the headers which we are used in table. If I want to remove any column related to any header here, I'm going to select that header here and just say delete column. Now after deleting that column, if I say apply OK, then only three headers are remaining now. But now we want to add some extra headers here, such as what was the material, what is the mass according to quantity also, and some user defined columns also we can add here. Again for that we are going to select the tables, say properties, and in properties go to columns tab again. So these were the three columns which are shown here. We are going to add another columns here. So here are some properties given by Solid Edge default only. You can see here this property list. So from these properties I'm going to select some properties and add into the above columns here. So for that I'm going to select here mass by items, say add column. This column will be added to this table again. I want to add mass by quantity also, say add column. First we have added mass by item, second is mass by quantity. Third, I am going to add here material also. So I want to specify the material also in the table for each part. For that I am adding this material, say add column. Now materials were assigned before only at the time of assembly. So you are just updating now. So for that we have added the material here. After material, I want to add company name also. So I'm going to add this title as a column here. Say add column, and the company name also will appear here. Say OK. Now you can see here all the columns we required are mentioned here in this table. If you want to decrease the width of the column, just drag it by holding these gray points so as to adjust the table according to the sheet size. So we can customize the sizes here. Now everything was predefined, means name was predefined, quantity was given by the system, mass by item, mass by quantity, and material is also predefined, and system has reflected here in this table. But only the company name is not defined here. So if I want to add this company name, which is not known by the system, I'm going to select here and say right click on properties. And for adding the company name, I'm going to click on this tab, that is data, and in data here I'm going to click on this column, that is company. Say right click and say allow cell overrides. I'm going to add here as 4DI. Say OK, and you can see the company name is also been updated now. So in this way you can update the columns manually also if the related property is not coming in the table. Again, say right click, say properties, cell overrides. We are just going to copy and paste it here. Say paste, right click, cell override, again say paste, and last one do the same thing. Say apply and OK. So in this way the bill of material has been updated here, part list table. This is the assembly and this is the bill of material for that particular assembly. You can click on this left point and drag the table anywhere you required. Now suppose if I want to add some user defined property which is not been present in the list properties here. For that I'm going to right click, go to properties, select the columns option, and for user defined property which is not present in the property list but still we want to add, then you just select the option user defined, the first option, say add column. Now the name also for the column is showing as user defined. So if I want to change and assign particular name for that process, you just need to select here in this tab, and instead of username, user defined name, I'm going to backspace it and going to add the required name for that particular property. Suppose I'm going to say hardening process. Hardening process. After adding the title name for this property, again just go on this columns option and click on this title user defined so that this name will be updated on this property. I'm going to click on this here and the property name has been updated. So I have added one user defined property also here which was not present in this list. Say apply and OK. You can see here the table has been updated with the user defined property. Now to add the data for that particular column, I'm going to click on properties, right click and say properties, go to data, and here in data I'm going to drag here, just right click and type whatever you want, directly double click it. So hardening process I'm going to say here as tempering. I'm going to copy that process and just paste it wherever you require. So in this way you can add the data which is not been linked by the part, but still you can add it as a user defined property. Say apply and OK. So in this way you can make the tables for assemblies, that is part list table, also known as bill of material. Next table we are going to see here is whole table. For that I'm going to open one specific part. Say file, open. Now we are going to take this part for drafting. At the top face I have given different types of holes here. We'll delete this feature first. This is not required there. And we are going to add one more circle here and make one simple hole without using hole wizard. Say finish, say extrude, select the sketch, say OK, and we are going to cut it here. Say finish and cancel. Hide the sketch, saved it. Now we are going to take this part for drafting. So for that, say new, drawing of active model. Say OK. And we are just going to see the table. So for that, I'm just going to take the primary view as top view only. We are not going to call all the type of views. We'll scale it as 1:1 and keep it here. Now at the top face only we are having this standard holes and one extrude cut also. So after that we are going to call the whole table. For that, select the whole table, click this point and give this as an X direction and this line as a Y direction, and just select the face which contains the hole. After that, say accept and the table will automatically appear. So these are all the standard holes which are being shown in the whole table. But in the whole table, we also need to add some more properties highlighting which type of hole is this, what are the callouts for the holes, and what is the count of each hole. Means how many numbers of holes similar are present there. For that, I'm going to select the table here, say right click and properties. In properties, again go to columns. Whatever the columns which were shown in the table at the outside, we can see a hole, X, Y and size. These columns are also been highlighted here also. If you want to remove any column, just select the column and say delete column. But if you want to add the column, directly go to add columns. We are going to select this whole callout option, say add. We are also going to select the type. It will show the type of hole, whether it is counter bore, counter sunk, tapped hole or dowel hole. So all the type of holes will be shown by using this type column here. Say add column. And then lastly we are going to add the count also here. So I'm going to add this count property, say add column. So all the columns are added here, but we don't want this user defined column. So I'm going to select that and say delete column. Now these are the columns which we want to reflect it in the table. So just say apply and OK. We can see here, these are the whole numbers, X and Y references for the positioning of the hole. These are the sizes of the hole and this is the callout. So this 1.1 hole is nothing but a simple hole having diameter 6 and depth as 35 mm. The second hole here, 1.2 number, it is showing as counter sunk hole having smaller diameter as 9 and larger diameter as 18.25 with the sunk angle as 90 degrees. Quantity is of 1. Means item count is 1. Similar way, the other holes are also being shown. So this is the way you can show the whole table also here. We'll adjust it the column sizes. Just click and drag this gray point so as to adjust the width of the column. Next we are going to take bend table. For that we are going to call one sheet metal part. So I'm going to select and say open. We are going to browse the part. So in the recent list it is showing here. So I'm going to select that. And we have also made this part flatten here. You can see if I go for tools and say flatten, this part is already been set as flatten and then saved. So it is compulsory for any sheet metal part before going to drafting that it must be set flatten and then saved, or else the flatten will not get reflected in the drafting. Now I'll take this part for drafting. Select the file, say new, say drawing of active model, say OK. And before placing this part, we are having one option here, that is this drawing view wizard options. If I click on this option, it will show whether you want to place the part as a design part, means however it is coming, or else you want to show the flatten pattern. So I'm going to select this option as flatten pattern and then say OK. So it will show the flatten view. I'll say this scale here as 1:1. Place this flatten view. Also place the side principal view for showing the thickness. Next we are going to go for this bend table. Select the view and you will get this bend table. Now this bend table is showing you. Now this bend table will show the number of bends, what are the radius for that particular bend, at what angle the bends are made, whether the direction is at the upward side or downward side, and the included angle. So here we can see for the first flange it is showing the direction as up. Now if I want to show the reference view also, so I'm going to say view wizard again, say OK, and I'll place it as an isometric view. Say isometric as a primary, say OK, and this view is placed. So for better understanding I have placed this view. We are going to see the table again now. So the flange 1, this is the flange 1. It is having bending radius 1 and its direction is upside. That's why this is showing in the upside. This is the bend 1. It is showing at the upper side. Next is bend number 2. So bend number 2 is joked and it is joked at 90 degrees angle. And it is showing the downside direction. It is because it is not going at the vertical side. It is going at the horizontal side. You can see here this bend is made horizontal. That's why it is showing this side here as downside. Similar are the other kinds of bends. In this way you can show the flattened view. But if I suppose select this view and go for that option view wizard, you will not get that view wizard option here now. That option view wizard for showing flattened view is only shown when you call the part for the first time. Suppose if I call this part again, say view wizard, browse the file and say OK. That time only you will get this option, that is drawing view wizard options. At that time only we need to say flatten view to be shown. Now for general table, that is fourth number type of table, we are going to select the general table option here. Select the table, go for columns. If I want to add the column, I am going to say add, say number 3, say OK. Now there are 3 columns. I'll place the table somewhere here. This is simple general table. So we are having 3 columns here and total 5 rows. So in this way you can place the general tables also. You just need to mention the number of rows and columns in properties. Go in properties, say columns as 3. And if I want to increase the number of rows also, we can increase the number of rows here. If you want to fix the row data height, you can adjust the height. If you want to adjust the column width, you can adjust the column width also here. Say OK. And if I want to fill the data here, so right click, go to properties again, select the data option and you can fill the data here. Just you need to click and type it here, say apply and OK. So in this way you can take the general table also. So these are the 4 types of table. Now suppose if I open any Weldment part, say open, and I'm going to take this table again here and we'll take this table to drafting, say file, new, drafting of active model, say OK. Now the only difference between the regular assembly and this assembly is that this is the Weldment assembly and the first one we have seen for the press tool was a simple assembly. So I'm going to again go for the table here. We have taken the drafting view. Now we need to show the table for this assembly also, Weldment assembly also. It is similar to regular type of assembly part list table. Only difference is we are going to add one more column here. For that I am going to scale it and make it little bit smaller again. We are going to add the part list table similar as we have added for the press tool assembly earlier. Here the table is appearing. We are going to delete this balloon line and say smart select. Select any one balloon. Say OK. You can see all the balloons are selected now using smart select. We are just going to put off the item count option and only item numbers are being shown. We are going to change the size for the balloon. I am going to say as 2. The numbers are now properly been highlighted. As it is a Weldment table, we just need to add one more column. That is, say right click, go for properties option, and in columns we need to remove this author option and we need to add this cutting length here. So this is the new column which is going to be uncommon between regular assembly and Weldment assembly. Then other properties or columns which we are going to add, such as mass by item, mass by quantity, then material. These were added in the earlier assembly also in press tool. The new thing is this cut length. This cut length is compulsory to be added in the columns as a property. Then only the Weldment parts, individual structures will be shown by the sizes. Say apply and OK. You can see here. So this is the table for Weldment assembly. Item number is coming, file name with the sizes only I have saved. That's why the sizes are also being shown here. Quantity is being shown. The total cut length, this is very important. So this column only will distinguish it from the regular assembly, that is cut length. It is very necessary to be shown so as to cut each length of the pipe. Now the first pipe is showing here this rectangular tubing, this vertical rectangular tubing. The size here for the cut length is showing 638 mm. Means manufacturer needs to cut this structure at 638 mm. The mass according to the quantity is shown here as 2.285 kg, but according to single item it's shown as 1.143 kg. Material was already applied during making of the structure in part molding itself. So material was stainless steel. So this is the part list table for well-made structure. Only change is adding this column, that is cut length. Now one more thing, this gusset was not a standard part or a tubing here. So that's why the cut length for this gusset, bottom support plate and top plate is not being shown. So if you want to add the sizes as the cut length for this also, select the table, say right click, properties, go to data, and in data you need to add this by right click on the column, empty column, and say allow cell overrides. Double click here and add the sizes. I'll say it was 40 by 40 by 10, length, width and thickness. For this also I'm going to say allow cell overrides, and here we are going to say 25 by 25 by 6 mm was the bottom support plate. The top plate I'm going to select, again say allow cell overrides, double click, and this size was 60 by 60 by 12. Say apply and OK. So now all the columns are fulfilled now with the cut length sizes, mass by item, material. Still you want to add some property, just right click, go to properties, go to this option, that is columns, and select the property you want and just say add column. That property will be added in the list and will be reflected in the table. Now one more important thing. Now if I don't want to display the first tube in the table, means tube will be present but I don't want it to be displayed in the table here. So I can do one thing, that is go to this list control option. We'll minimize the columns first. I'll just say bottom support plate part, or else the frame 1, I want to remove the frame 1. Select the frame 1 option and say selected item as excluded. As you say excluded and say apply and OK, that particular set for the tubings is not being shown in the table now. The numbers are directly starting from 3, 4, 5, 6. 1, 2, 3 set has been gone now. You can see here the tables, it is showing here as NA instead of 1. Here also NA, as these 4 tubes were of same type and size, that's why. If I want to include them again, just click on the table, say right click, go properties, go on this list control, and you can see here this blue colored mark is showing that all these things are shown in table, but this frame option, it is appearing here in white color as it was hidden. So again I'll click on that particular option and say include the item into the table, say apply and OK. Same goes for the regular assembly part list also. So if I don't want to show this top plate here in this table, that is of item number 4, I'll click on this table, go to properties, say list control and say top plate, I want to exclude it, say apply and OK. Now this top plate is not being shown and the balloon instead of 1 it is showing NA as it is not present in the table. Say right click to include it again, go to properties, go to list control, select this icon. You can see all the icons are coming in yellow but this is showing in white color. It is because it was excluded, so I'm going to select it and say include, say apply and OK. Now that particular plate is again included in the table. So if you want to include or exclude any part from the table, you can do it from the part list control. So these were the different types of table to be shown in Solid Edge. The next thing we are going to see here is how to add the GD&T frame and symbols. So for that we also need to add the references. So we are also going to see how to add the datum references here. So to start with, I am having one PDF here. We are just going to go through the symbols and then we are going to see how to add the symbols and datum references. So to start with, we are going to refer this particular PDF. It is showing GD&T. So what is GD&T? GD&T, the full form is Geometrical Dimensioning and Tolerances. It is an international language used to describe the part accurately. It comprises of 14 symbols. Earlier it was 14 symbols actually, but now according to new standards, symmetricity is excluded from this list. So now there are only 13 symbols, but still we are going to see the symmetricity also here. So these are the symbols, that is straightness. We can see our single horizontal line is being shown. Second one is flatness, a rectangle is shown. Third is circularity, a circle is shown. And fourth one is cylindricity. So these four characters come under form category. So according to categories, there are total 5 categories, that are form, profile, orientation, location and runout. So in form, straightness, flatness, circularity and cylindricity lies. In profile, there are total 2 characters, that is profile of line and profile of surface. These are the symbols you can see here. The third category is orientation, under which comes angularity, perpendicularity and parallelism. Fourth one is position, concentricity and symmetricity. And the last one is runout, that is circular runout and total runout. So these are the 14 symbols and 5 categories which comes under GD&T. Now regular dimensioning and GD&T, the difference is regular dimensioning tolerances only control particular one dimension with the tolerance, but GD&T controls the shape and size of the body. Means not only one particular dimension, it will control the shape as well as size of overall body. That is the main difference between GD&T and regular dimensioning. Now what are datums? Datums are nothing but a theoretical exact plane, maybe axis or point, that GD&T or dimensional tolerances are referred from. Means we can say datums are nothing but references. Now you can see one example here. For straightness, one frame has been added. Always in this frame, the first thing will come is the GD&T symbol. The second thing will be the tolerance value. Whatever will be the GD&T tolerance value will come at the second box. And suppose there are modifiers, then that modifiers will be added with the tolerance value we can see here. Now if we talk about references or datums, we can see here this example. Now if I have this capital letter as A here in this frame, it means the reference has been added as an angularity. This base is coming as a reference A and the angle for this particular face is taken from that base. So in this frame, first we'll have the GD&T symbol, then we have the tolerance, and then we are going to add the reference here, means datum. So from which datum or reference we are going to apply the GD&T here. Now we will see how to apply GD&T with datums in Solid Edge. We'll move to software here. We have one part and we need to apply concentricity for this inner side one with reference to the outer one. So for that, first I'm going to add datum here. So I'm going to say the outer circle as a datum. We'll take this datum as datum A. If you want to make this datum with horizontal ladder, just click on that datum ladder and select this option, that is break line. So now this outer circle is being shown as a datum here. We'll keep it somewhere here. And now I want to apply the datum feature control frame on this inner circle showing concentricity. For that, just go on this option. Select the concentricity symbol first. As soon as you select the symbol, the preview of the upcoming frame is being shown here. Then we need to add the divider symbol. After adding the dividers, we need to add the tolerance value. So this is the tolerance we required. If I want to add the modifiers here, you can add the modifiers by going on this option, that is diameter. If I want to add the material condition, there it comes the material condition. If I want to add the tolerance zone, you can add the tolerance zone here, whether it is flat, plane, circular, as required. So I'm going to add the symbol as diameter here, as the concentricity will have circular zone for the tolerance. That's why I'm going to add this diameter symbol. You can see in the preview window. Next we are going to add one divider line again, and in this last divider box I'm going to show the datum reference. So datum reference, we have taken the datum here as A. I'm going to add the datum here as A only. Say OK and select the feature where you want to apply the GD&T. So this is datum A, and with reference to datum A, we are showing that this circle is concentric with the first circle. Means both the circles are having similar center, but still if the center of the inner circle moves in a circular diameter zone of 0.02, instead of coming at the exact position, it can be placed in this diameter zone. That is this tolerance zone, 0.02 mm diameter. So after adding the symbol, we can see the frame. So the first section of this frame is showing the GD&T symbol. Second one is showing the tolerance value as well as the zone type. It is circular zone, that's why I've taken the diameter symbol here. And the next section is showing the datum reference. So for adding the datum reference, we need to go here and add the datum reference. Again, I'll take this base as the datum reference now. We are not going to repeat the datum reference later. So I'm going to take, instead of A, as we have used A earlier only, we are going to take here it as B. So this is the datum reference B. We'll move it little bit aside. And I want to say that this face is coming perpendicular to this datum, this face. So we need to add the feature control frame here. Select the option, go for perpendicular option here. Add divider, we need to add the tolerance here, again divider sign, and then we need to add the reference. So I'm going to take the reference B here, indicating that this particular face is perpendicular with the base reference B. So this face, vertical face, is perpendicular with this horizontal datum or bottom face. In this way you can add the feature control frames also here. Now what this frame means is, we'll go for this example. It is similar kind of example. Here the A reference is shown for this bottom face and the datum frame is added on this vertical face, indicating this symbol, the tolerance zone value and the reference data. Now it means is, suppose if this back surface on which the feature control frame is added, suppose if it is not manufactured as smooth as we required here and it have some deviations here, that deviation should come within the tolerance zone which is mentioned here. So this value we have added is nothing but the tolerance zone under which the surface must lie. We are imagining that there are two parallel planes under which the surface must lie, and the size of this tolerance zone is nothing but the value which is appearing here, that is 0.03. So within 0.03 this surface must lie. Then we can consider that this part is okay and can be taken for the further features. So all these things are shown by this control frame here. You can see this is the datum and this is the control frame. All the other GD&T features are also same only. Whatever feature you want to control, you just need to add the frame here. In first section you need to show the symbol, second you need to show the tolerance value, and if any datum reference is required, we need to add the third section also showing the datum references. So in this way you can add the GD&T frames here.